Let's try this one here. The diagram represents a triangular car park PQS and a building RQ of height 70 meters. T is a point on PS such that PT is to TS, it is equals to 5 is to 3. PS equals to 144 meters. So QPT, angle QPT is equals to 63 degrees and STQ is equals to 114 degrees. So in this case, they're saying show that the QT is equals to 103 meters rounded to the nearest whole number. So this answer, it was rounded. It was actually 103 comma something or 102 comma something. So we shall see about such. So now, if we want to determine QT, our QT is this one, and we are given this angle here. It means we have to determine this angle here, okay? And then we must know the side PT. So in this case, we know that we are given the ratio, which is PT is to TS, which is equals to 5 is to 3. So in this case, we have to get the total ratio. So the total ratio in this case, it is equals to 5 plus 3, which is equals to 8. And then from this part now, you can determine the length of PT. The length of PT, it is equals to 5. This 5 divided by the total ratio 8 multiplied by 144. Where do we get this 144? We have been told that PS, it is equals to 144 meters. Not forgetting that PS, it is given by PT plus TS. That's why we end up having this. So when we use our calculator, it's 5 divided by 8 multiplied by 144. We're getting 90. So in that order, we can determine a TS. Sorry for writing P. TS as well, which is 3 divided by the total ratio multiplied by 144. So if we use our calculators, we are getting 54. So now we know that PT is 90, TS is 54. Now we can determine this angle so that we can be able to use sine rule. So this will be 144 exterior. It is equal to this angle here. So the exterior angle 114 degrees. It is equal to sum of the two opposite interior angles. So it will be 63 plus angle PQT. So now our PQT will be equals to 114 minus 63 degrees. So it's 114 minus 63, and then we're getting 51. So this angle here, it's 51 degrees. Now you can determine QT. In this case, our QT will be QT. We start by the side because we're looking for it. Divided by the sine 63 degrees equals to, in this order, it will be 90 divided by the sine of 51 degrees. And then now you have to make QT the subject. Our QT, it is equals to 90 sine 63 degrees. And then we divide by the sine 51. So it's basically cross multiplication. And then I divide by sine 51 both sides. That's why I remain with this. Equal to, when we use our calculator, we are getting are getting 103, 19. So when we round off to the nearest whole number, we're getting 103. Done. Okay. And then now we move. We know that this length is 103. So now they're saying determine the angle of elevation of R from S. Round off your final answer to the nearest whole number. So the angle of elevation of R from S is this part here. The angle of elevation, this is the one that we have to determine. But do we have enough information? No. We must determine the QS so that we can have enough information to determine what? To determine this angle. So in this case now, you are going to focus in triangle QTS. So since we know this side and this angle here, this angle is the included angle. It means we can use cosine rule. So I'm going to say QS, it is equal to the square root of, I'm using square root because I was going to say QS squared, it is equal to QT squared plus TS squared minus 2QT times TS cos angle QTS. Okay, so now let's substitute, and then I apply the square root to both sides. That's why I remain with QS equals to square root of QT is 103 squared plus TS is 54 squared minus 2 times 103 times 54 cos angle 114 degrees equal to. So now we are using our calculator. It's basically square root of 103 squared plus 54 squared minus